What is one of the most important discoveries in industrial chemistry that has had a great impact on global food security? The answer is the Ostwald process, discovered by the German chemist William Ostwald in 1902. Ostwald's innovation has been crucial in the production of nitric acid. The acid, which plays a key role in solving such a large-scale problem as world hunger, since it's used in the production of fertilizers that help increase yields and ensure food security. According to the UN World Food Programme Report 2023, 345 million people are facing high level of food insecurity in 2023. So even now, in the 21st century, this problem still remains relevant. This highlights the importance of the Ostwald process in contributing not just to the field of chemistry, but also to a whole world. Now, let's talk about the process itself. First, we start with ammonia gas. When ammonia mixed with oxygen and passed over a special catalyst made of platinum and rhodium gauze, which is used to increase the speed of the oxidation of ammonia, something interesting happens. At high temperatures, about 850 degrees to 900 degrees, the ammonia and oxygen gas are passed over the heated catalyst. The catalyst absorbs the molecules onto its surface. The process of absorption weakens the bonds in the ammonia and oxygen molecules, making the atoms more reactive. Once the gas is absorbed, the oxygen reacts with the ammonia to form nitric oxide and water. The overall reaction is. Next step is oxidation of nitric oxide to nitrogen dioxide. In simple words, the nitric oxide we just made reacts further with oxygen. This time it turns into nitrogen dioxide, and it happens at much cooler temperature, around 15 degrees Celsius. Equation for this reaction looks like this. The third and final step is absorption of nitrogen dioxide to form nitric acid. After the formation of nitrogen dioxide, in the previous step, we use a specialized setup called absorption towers. Inside these towers, water interacts with nitrogen dioxide to form nitric acid. As the nitrogen dioxide interacts with water, a chemical reaction occurs, leading to the formation of nitric acid and nitric oxide. Chemical equation for this reaction is. But what happens inside this tower? The water in the towers acts as a solvent, absorbing the nitrogen dioxide. The absorbed nitrogen dioxide then reacts with the water to form nitric acid, which is collected in a liquid form. So, there we have it. Starting with ammonia and oxygen, we end up with nitric acid, a super important chemical for fertilizers and many other things.
So the final product in this process, we have weak 2HNO3 of 55 to 65% concentration. The output is influenced by several factors, like temperature, pressure, and the concentration of nitrogen oxides. Then it splits into two stages. In first case, it is being distributed to the fertilizer production, chemical intermediate, and metal processing industries, where the 60% concentrated nitric acid is needed. The rest of it goes to another chemical phase of distillation aimed to purify the acid. In order to achieve the highest purity, the weak nitric acid is being transferred into the hydrating column alongside a dehydrating agent, concentrated sulfuric acid. This process creates nitric acid vapor, HNO3, nitrogen dioxide, NO2, and oxygen. Then these products enter a bleacher and a counter-current condenser system. In this process, cooling water is added, condensing nitric acid vapor into liquid form, keeping its purity and making the final nitric acid with a 98 to 99% concentration. NO2 is directed into an auxiliary column that converts it back to the weak nitric acid solution, and gases like O2 being vented to the environment.
Now let's talk about the factors, and the first factor we would like to consider is a social factor. It has both negative and positive sides. Positive side is the global demand for nitric acid, which is essential in industries like agriculture. According to the data collected by the Statistics Research Department, March 24, 2023, the global nitric acid market size was valued at 29.6 billion USD in 2021 and 30.58 billion USD in 2022. This trend with a significant growth can be explained by the role of nitric acid in fertilizer production. Nitric acid helps create fertilizers that are essential for increasing crop yields, making sure we have enough food to meet the growing global demand. Another social advantage of nitric acid production is its contribution to job creation and employment in general. As the demand for nitric acid continues to increase, the industry not only boosts the economy but also creates great employment opportunities for everyone. This growth connected to the use of nitric acid in agriculture extends beyond only the farming and agriculture sector. It led to job creation in chemical manufacturing, transportation, and even research and development. Chemical manufacturing often requires a great labor force, including chemists, engineers, technicians, and various support staff. This area is not only about researchers working on nitric acid production, but also environmental experts who ensure that production methods are sustainable and safe for the whole society. However, nitric acid is not perfect. It has its disadvantages, and one of them is the impact on health. The process of nitric acid production results in the release of nitrous oxide, greenhouse gas. The increased consumption and efficiency might lead to higher overall emissions, and in turn, the release of nitrous oxide have a significant impact on human health, leading to respiratory and cardiovascular disease like asthma and bronchitis. According to the NatCom 2012, the emission of NO2 from nitric acid production has been estimated at about 11.7 gigagrams in 2007 and been downsized to 7 gigagrams in year 2010.
Economic factor. Nitric acid is extremely versatile and essential for many industries, generating high revenue. For example, the weak acid is used in agriculture for fertilizers, explosive manufacturing used both by mining and defense/military realms, nitrobenzene, pharmaceuticals, chemistry, metallurgy, and so on. The global nitric acid market size was valued at $29.8 billion in 2022 and is anticipated to grow at a compound annual growth rate of 2.4% from 2023 to 2030. This means that the market for nitric acid is huge, having potential growth in the future. Furthermore, the manufacturing of nitric acid is a very cost-efficient process because of the capture and utilization of byproducts. This specifically happens during the catalytic oxidation of ammonia to nitric oxide. This process, conducted through a platinum-rhodium catalyst, is exothermic, which means it releases heat. This thermal energy then produces steam, which powers up the plant. This not only decreases the reliance of plant on external energy, but also decreases the cost of overall production. However, to set up this infrastructure for production, you would need to build specialized reactors, distillation columns, and emission control systems that demand high investments. The initial cost for a nitric acid plant would cost about $216.6 million. That's 2021. This high entry barrier can limit market expansions and at first not be profitable for manufacturers. In conclusion, nitric acid is an essential industrial process that plays a huge role in many sectors, from fertilization to manufacturing. It requires high scientific knowledge for the most effective production that is based on numerous factors like pressure, temperature, concentration, and so on. Through the erstwhile process, rhodium-platinum catalyst, nitric acid production became much more complex, requiring also purification processes like distillation or dehydrating to produce the purest nitric acid. New technologies and innovations also make it easier to produce and convert excess products to energy. Despite the huge market for this product, it still has some pollution challenges that in the future, using new innovations in this process might even further increase efficiency and decrease the negative impact on the environmental factor. Thank you for your attention.